When a patient comes in and needs blood, one of the things that's going to happen is that we're going to check to see what blood group they are. There are 8 possible blood groups, starting with A, B, AB, and O. And the reason we do this is because if we give our patient certain kinds of blood, it can interfere with their immune system, and their immune system can attack that kind of blood. So we're going to look at which blood groups can be given to which other blood groups. So if we look at a red blood cell, people who have the blood type A have little proteins that stick out on the outside of their red blood cells that they called the A protein. And some people have B blood, and they have B proteins that stick out on the outside of their blood. And the immune systems of the A blood group people know that this A is going to be sticking out on the outside of the red blood cell, and they think that that's normal. Their immune system thinks that the A is normal. But the people who have B blood group, their immune systems know that the B is normal. They've never seen the A, so they think that the B blood group on the outside of the blood cell is normal. Now, some patients are going to have an AB blood group, which means that they express both the A and the B on the outside of their blood cells. So they just express both proteins, the A and the B protein. And then there's a fourth group, and they are the O blood group. And an O blood group doesn't express either the A or the B protein on the outside of their cells. So their blood cells don't express anything, so their immune systems are not used to seeing any of these two proteins on the outside of their cells. So if we look really quick at how you get these blood groups, you get one copy of each gene from each of your parents. So you can have a copy of an A gene from your dad and a copy of an A gene from your mom. Or one of your parents could have an O blood group, which says don't express anything on the outside of the cell. And one parent can have an A blood group, which says express the A on the outside of the cell. So there are 2 different ways you could get an A blood group. If you have the B blood group, the same thing goes. You could get a copy of a B from your mom and a copy of a B from your dad, or one of your parents could give you an O and one of them could give you a B. And then if we look at the AB blood group, you have to have gotten one copy of the A from one parent and one copy of the B gene from another parent. And then similarly with the O gene, because the O gene says don't express anything on the outside of the cell, you had to have gotten an O gene from both of your parents. Now, blood groups are a slightly different inheritance type. They are called codominant, and you don't have to know that. But the only reason I bring it up is to tell you that this is not normal. Usually, for example, one that is dominant over the other and the presence of one just takes over the other. You don't wind up with this AB blood group where both are expressed. So I just want you to know this is a little bit abnormal in how our genes normally work. Because it's a codominant, they can express both the A and the B protein on the outside of their cell, which isn't terribly important here. So now that we know that you can have these 4 blood groups, let's talk about why you can't just give any of these bloods to the other people. So if you took the B blood and you put it in a patient who had A blood, their immune system would see these Bs and say, we don't know what these are, we're going to attack those, and it would attack that blood that you've just put into your patient. So their immune system is going to attack the blood that is now filling their entire body. So this is bad. This is a huge systemic immune reaction. On the other hand, if we had given this B blood to a patient who had AB blood type, that patient is used to seeing both an A and a B on the outside of their red blood cell. And when they see the B, they say, okay, we've seen that before, that's okay. It doesn't matter that it doesn't have the A on it, because there's nothing in there that it sees as foreign. So our immune systems look for things that they've seen before and things they haven't, and they're pretty black and white about it. So there's things we've seen before and things we haven't, and it's seen a B protein on the outside of a red blood cell before. So if you give B blood to an AB patient, their immune system will think that's just fine because they've seen that B before. Same thing with the A blood group. You can give A blood to an AB patient because it has seen that A before. But the reverse is not true. If you give AB blood to a B blood patient, it's going to see that A and say, we've never seen that A before, we don't know what that is, and it's going to attack that A protein expressed on the outside of that blood. So again, you're going to have a systemic immune reaction to that blood. The cool thing about AB patients is that they can receive blood from anybody. If you put O blood into an AB blood patient, there's no proteins expressed on the outside, and it's seen a red blood cell before, so the immune system says, all right, that guy's okay. He's missing some proteins on the outside, but it's nothing we haven't seen before. So you can give O blood to an AB patient, you can give O blood to a B patient, and you can give O blood to an A patient. You can give A blood to an AB patient, and you can give B blood to an AB patient. So this AB guy is pretty lucky because he can receive blood from just about anybody. We're going to discuss where there's one case where he can't, but you can see that he can get blood from the O group, he can get blood from the A group, and he can get blood from the B group. So in the event of an emergency, he's pretty good to go. Now this O guy, on the other hand, can't get blood from anybody except another O, because if you put this A blood group in there, the immune system is going to see that A and say, we've never seen that before. If you put the B blood group into a patient with an O blood, it's going to say, we've never seen that B before, we don't know what that is, that's got to be foreign, we've got to attack that. And the same thing with the AB blood. So the O group is the group that can't receive blood from anybody but another O. Now, I told you there were 8 blood groups and we've only discussed 4. So if we look over here, we'll discover that there's a whole other completely separate blood type which is called an RH factor. So if you're RH positive, it means that you express the RH factor on the outside of your cell. And I'm just going to draw little pluses out there. It's called an RH factor because it was originally discovered in rhesus monkeys. But this RH factor, you either have it, so you're expressing this protein on the outside of your cell, or you don't have it, similar to the O group where there's just nothing expressed on the outside of your red blood cell. So now you can have a parent who has an RH minus and an RH, and a parent that has the RH plus that gave you one of each gene, and that would give you an RH factor of a positive RH factor, so a plus in this case. Or you could have both parents have given you the RH plus factor. And on the Rh negative, you have to have gotten the negative from both parents the same way that on the O gene, you had to have gotten it from both parents, because it says don't express any protein on the outside of the cell. Now this is going to come into play during pregnancy, and I will come back and explain that in just a second. But now that we know that you can have an Rh plus or an Rh negative, positive or negative, any of these two can be combined with any of the original 4, which means that if we come back over here to our ABO blood group, now we can have A plus, B plus, AB plus, and O plus, or A negative, B negative, AB negative, and O negative. Possible blood groups, we have A negative, B negative, AB negative, O negative. We also have A positive, B positive, AB positive, and O positive. So now things get a little bit more complicated, but the concept is still the same. This A guy has never seen a positive. So if I give this A positive blood to this A, he's going to attack this positive Rh factor on the outside of the blood cells, and that's going to be bad for our patient. But on the other hand, if I give A negative blood to an A positive patient, it doesn't see a positive factor, but it doesn't see anything it hasn't seen before because it's seen an A blood type before. So it knows that it can so we know that it can take that kind of blood because there's nothing on this blood cell that it hasn't seen before. It's seen an A and it's seen a red blood cell. This positive factor is just going to be on the patient's blood but not on the donor blood, so that's going to be just fine, which means that all of these upper groups, all of the negative groups, can donate to the same blood type in the lower group. Now, similar rules still apply up here though, where the O negative can donate to the AB, to the B, and to the A negative. And the same rules still apply where A negative can donate to AB negative and B negative can donate to AB negative. And now our positive groups are going to have similar traits where the O positive can donate to the AB positive, it can donate to the B positive, and it can donate to the A positive. And the A positive can donate to the AB positive, and the B positive can donate to the AB positive. But also, the A negative can donate to the AB positive, and the B negative can donate to the AB positive. So, in an emergency, this AB positive guy has kind of won the lottery because he can get blood from anyone. And I left out this O negative guy even can donate, and so can the AB negative guy. So every blood type can donate to the AB positive because he's seen all of the 3 possible proteins on the outside of his red blood cell. However, you'll notice that the O negative guy doesn't have any arrows pointing to himself because the O negative can only receive blood from another O negative donor. Now the O positive can get blood from the O negative, or it can get blood from another O positive donor. But in the scheme of an emergency where there's not a lot of blood available, the O positive is going to have a somewhat difficult time because they can get blood from another O positive or from an O negative, but the O negative is really in trouble because he can only get blood from another O negative patient. But the AB positive is going to have the ability to accept blood from anybody. Take a second and really study this chart and make sure that you can understand how come each of these donors on the left can or can't donate to the recipient blood types across the top of the chart. Notice that the AB positive recipient across the top there can receive from everybody, and how the O negative donor across the middle there can donate to everybody. But go through, pick a cell in the middle somewhere randomly and see if you can tell yourself why it is that that square is either red or green.